Spartan-6 has been a very popular device, but due to many different reasons, designers look to different solutions to advance their production requirements. For those products, a migration must take place to move to a newer, more current architecture. In any case of migration, the design team will need to put a lot of forethought and planning into what they're doing. There are many questions that need to be considered, such as, do we just do a straight migration to the new architecture, or do we take advantage of the situation and introduce improvements or enhancements to the design and overall product? This course specifically deals with migrating an existing Spartan-6 design to a cost-optimized, newer Xilinx architecture. Typically, when designing on a replacement part, it's not just the count of resources that are important, but it's also the uniqueness of the design in question. Hardin has created this exclusive one-day migrating from Spartan-6 course to help bring about a deeper review and understanding of some of the more important factors when migrating the design. Overall, we will be comparing the architecture of some of the viable solutions, reviewing some of the key differences between the mandatory software that must be used for the migration, and touching on some of the more difficult points of the overall design success. We will investigate some of the key Vivado reports that can help migrate the design and provide some guidance on how to take advantage of a design technique called baselining, and that can help converge quicker and more precisely in design closure. So you have an existing Spartan-6 design that you want to migrate to what? So when choosing to migrate, the resource guidance can be relatively straightforward, but the uniqueness of each design in question needs to be considered. If you got a Spartan-6 design of 100,000 logic cells or less, then maybe you could migrate to a Spartan-7. Your Spartan-6 design has over 100,000 logic cells, then, well, now we got to start looking at Arctic 7 or maybe something else. The Spartan-7 doesn't include transceivers, so if your Spartan-6 design had GTPs, then you're going to need to migrate maybe to an Arctic 7 or something else. The Spartan-6 pad ring layout that allowed for more I/O per unit die area. So there are a few instances where high I/O utilization designs will need to migrate to the 7A200T device. If using the Hardin PCIe, should the design move to an Arctic 7 or maybe an Arctic UltraScale Plus? Is there a soft microprocessor in the design? If yes, then do we consider remaining as a microblaze, or perhaps we move to something like the Zinc 7000 series part? In the end, the design is going to determine the available parts and architecture to target, and we need to consider this upfront to make sure that we're moving in a good direction and making sure that we don't have to back up and change devices. So this chart, it shows the cost-optimized family architectures that were considered in the design of this course. Your particular needs should guide you towards which device is best suited as the target of your migration. So the families considered are, for the 7000 series, the Spartan 7, the Arctic 7, and the Zinc 7000 series. For UltraScale Plus, it's the Arctics and the Zinc UltraScale Plus members of those families. So again, it's more than just a resource count. Are the original system requirements still available, and does the Spartan-6 meet all of those requirements? Or did production allow for some design limitations within the original design that can be met in the new target architecture? Do we choose to do a complete board respin, or perhaps would an interposer solution provide for a more cost-optimized or efficient solution? If an interposer path is chosen, is there enough space available on the existing board in all directions, including height? Can we manipulate the existing voltages and current provided to make the interposer viable? Available I/O and pinout on the existing board force compensation of wire length matching within the interposer. Does every IP retarget, or are there required integration paths for those that don't? Are all the tools and software needed available, and what other changes are required due to selecting an interposer path need to be considered? So here's a snippet taken from a Molex ISI website that provides the gist of how an interposer could be an option. This doesn't change the fact that our architecture migration must take place. However, it potentially alleviates the need for a complete PCB board respin. As already discussed, when going down the interposer path, there is much more to take into account than just the resource count. Configuration mode and the number of configuration bits required are integral elements in transitioning the design to a different architecture. Knowing how you want to configure and what size storage is required to program is something that must be considered when selecting the final targeted device. The newer architectures are based on smaller process nodes. Therefore, more resources are available in the same unit die area. When migrating devices, you need to take into account the configuration storage area, whether it be for a PROM or some other form of storage, as the configuration bits will most likely grow, possibly by almost 2 orders of magnitude more than the existing memory footprint. As an example, migrating from a Spartan-6 LX45 to a 7 Series 7S50 increases the configuration bit count by more than 5 megabits. When migrating the architectures, you will also be migrating software. There are a lot of resources available for designers to research and consider for their migration needs, and here are some that are readily available. Whether it be documentation to guide you through some of the differences in software, guidance on design methodology, courses like this one, or something like a course to provide guidance on what the differences are in the embedded design flows between the previous SDK or software development kit flow used in ISE to the new Vitis flow. For any questions and for further guidance, you should always talk to your local Xilinx representatives. Xilinx provides copious amounts of literature and documentation to designers, and here are a few documents considered in the creation of this course. Be sure to visit the Xilinx website to find documents that can help assure a more enhanced design migration experience.